Hello and welcome to the Mercury Aerospace demonstration of the new generation Leversab 6300 air data test set. Neatly presented in this ruggedized pellet case, the 6300 series brings a new level of accuracy and stability to air data test sets. This video will demonstrate the full functionality and the ease of use of this 6300H. The well laid out front panel provides easy access to the main power switch, main power connector, an earthing point, a battery changeover switch if the battery is fitted, emergency crossbleed valves for both pitot and static, the two outputs for both pitot and static, and the 6310 controller and its connection cable. The availability of power is indicated by a green LED on the control panel. Once the main toggle switch is initiated, power will be made available to the device. If a battery is fitted, the battery will begin charging only when main power is available and is indicated by the orange LED on the control panel. To switch on the test set, we press the power button on the 6310 controller. The opening screen will confirm the software revision installed into the test unit. The entire range of Leversab's new generation of testers are Wi-Fi enabled, offering control through either Microsoft Surface Pro devices or the Apple iPad. For the purpose of this demonstration, we will conduct it using an iPad. Control of the test set for the iPad is gained through connecting to the Leversab Wi-Fi signal that is generated by the test set. Once you have connected, return to the home screen and select the Leversab app, which is free to download from the iTunes Store. To begin sending commands to the test set, we need to initiate control through the power button on the iPad screen. Once this has been initiated, the 6310 controller will become locked out. No further commands can be given through the controller until such time as control has been handed back from the iPad to the test set. The iPad is now fully in control. But before we can begin any testing, we must undertake a self-test of the system to ensure that all modules are working correctly as desired. Press the self-test button and follow the on-screen instructions. You will need to open both ports to the ambient environment and press go. Once initiated, the self-test will take a couple of minutes to complete, but will test diagnostically a number of different modules inside the unit. Once complete, the self-test will produce a list on the screen of all the modules that have been tested and their successful completion or otherwise. With self-test complete, it's now time to connect the test set to the aircraft. Take the hoses from your adapters and connect them to the respective ports on the upper panel of the test set. Before continuing on to any tests, we need to set ground. Ground signifies the ambient pressure rather than the field elevation of the environment. The 6300 has an internal sensor which is always measuring the ambient pressure. This measurement of the ambient pressure is used to establish the ground target value. We've now reached a convenient time to explore the functions that are available to the user on the function select screen, which is reached by pressing the function button. There are 9 functions available to the user from this screen. Number 1 is the view limit screen. There are 7 user programmable limits to ensure protection to both the aircraft and the instrument. Under function 2, you can modify those limits.
This can be password protected to prevent inadvertent changes. Function 3 is the modification of the brightness, only applicable when using the 6310 controller, and function 4 is the running of profiles, which will be demonstrated later in this video. Function 5 enables you to load up to 15 profiles from an Excel spreadsheet. Each one of these profiles can contain 50 individual flight points. Function 6, height correction, enables you to cancel out any difference between the height of the static port on the aircraft and the location of your tester. Function 7 enables you to program one of 3 independent leak timers to assist in the process of leak detection on both pitot and static channels. Function 8 provides access to calibration functions. Function 9 is only applicable if the optional encoder has been included. From the main screen, there are also a number of other options available to the user. This includes changing the mode of operation between measure, leak or control, or selecting such items as the pitot measurement unit, the static measurement units, or the static and pitot rate units. This is achieved by pressing either directly on the blue panel or by pressing the corresponding number on the control panel. We now move on to the leak testing phase. Leak testing can be carried out either independently or simultaneously. For the purpose of this demo, we will do it independently. In order to carry out the pitot low-level leak test, we need to set the target for the pitot. This is done by pressing the blue box or number 2. The pitot target set for this test is 100 knots. The tester will ramp up towards the target as governed by the rate limit. Once the tester achieves its target, it is advisable to wait 30 seconds to ensure stability. It is now necessary to move to the leak testing phase, and to do this we need to change the mode from control to leak. The ideal scenario for conducting the pitot leak check is to keep the static in control at ground. Once initiated, the tester will give you an indication of the instantaneous leak rate. Solely for the purpose of demonstration, I will use the pitot cross bleed valve to indicate a small manageable leak such that it is possible for you to see this on this demonstration. This should not be done or used in normal operation of the tester. For this demonstration, the leak timer snapshots have been set at 1 minute intervals, but it is possible to have those set at anything between 1 and 20 minutes. The flexibility of being able to take the iPad away from the tester and the programmable leak timers provides for an extremely useful tool in assisting with leak finding on the aircraft and/or the lines. Once leak testing has been completed on the pitot side, it is necessary to do the same test on the static side. By pressing cancel, the unit will return to control and will drive the pitot side back to the original target. The process for carrying out the low-level leak test on the static side is predominantly the same. Using the right-hand side of the screen, you dial in a target value, in this case 3,000 feet, and then instigate a change of control to leak mode. As the altitude ramps towards the target, I will demonstrate the ability to change the climb rate for the static on the fly. Pressing the blue box will enable you to dial in a new value, and this will be accepted once you press go. Having demonstrated the snapshot timers for the leak on the pitot side, I will cancel out of this on the static side for the purposes of expediency. Having completed the leak test successfully and having managed our leaks to an acceptable level, we are now in a position to conduct testing. This is a fairly self-explanatory process where you set targets, rates, and drive the unit towards those targets simultaneously or independently. As previously demonstrated, you can change targets and rates on the fly. During operation, the hold function can be initiated by pressing the hold button. This enables the user to pause the process while the 6300 is ramping from one target to another. The jog feature is a useful feature in that the user can change the target for both pitot and static in steps of plus and minus 1 foot or 1 knot. This is extremely useful for friction tests in older gauges. You will now be au fait with the testing process using the 6300. An alternative to loading profiles is to run one that is already pre-stored at location number 15 on the tester. This is a shortened version of a FAR-compliant test program. Once initiated, the blue target boxes will change to show the various rates and targets as defined in the program. Changing between those profile points within the program is a simple process of using the up or down arrows and pressing go. Once you have completed your testing, press cancel to exit. To complete this process, it is necessary to take the tester to the ground condition using the ground key. The time taken to achieve this will depend upon your final altitude and the rates that you have set previously. I have only briefly described the functions available to the user through the 6300 test screens. Further details can be found in the user manual, which is available from the Laversab website as a free download. Once we have achieved ground, it is necessary to switch control back from the iPad to the 6310 controller. With control having been returned to the tester, it is now possible to disconnect your hoses and switch off the unit. That's it, the job's done. Thank you for taking the time to watch this video. Please stay with us for a few minutes to review some key customer benefits that are available to you, our most valued customers, through Laversab and Mercury Aerospace.